Hey there, and welcome. Today, we're going to explore a totally invisible world, a world of pushes and pulls that controls, well, pretty much everything, from a soccer kick all the way to how planets orbit in space. So let's just dive right in. Seriously, have you ever thought about it? You give a soccer ball a huge kick, right? It just soars through the air, but it always, and I mean always, comes back down and, eventually rolls to a stop. Why? Why doesn't it just keep going and going? It seems like a simple question, but trust me, the answer is super powerful.
And there it is. The whole answer is just one single word: forces. That one idea explains the entire journey of our soccer ball. And today we're going to break down exactly what that means.
Okay, so let's start with our first section, the world of forces. If forces is the big answer here, then we gotta ask, what in the world is a force anyway? It's really that simple. A force is just a push or a pull on an object. So when you kick that soccer ball, your foot gives it a really powerful push. And if you were to pick that ball up, you'd be giving it a pull. See? Force is just the sciencey word for any kind of push or pull.
And you know how we measure how tall you are in feet or inches? Well, scientists need a way to measure the strength of these pushes and pulls too. And they measure it in a unit called the Newton. Yep, named after the super famous scientist Isaac Newton. So a tiny little tap might be just a few newtons, but a massive kick, well, that's a whole lot more.
All right, so we know a kick is a force, but what is it about that kick that sends the ball flying in the first place? Well, that brings us to this really cool idea of unbalanced forces.
Think about it. Before you kick the ball, it's just sitting there, right? The forces on it are all balanced out. But then, bam, your foot connects and you apply this huge unbalanced force. It's unbalanced because your kick is just so much stronger than any other force on the ball in that one moment. And what happens when you have an unbalanced force? You get acceleration, which is just a fancy word for any change in motion. The ball goes from 0 to super fast in like an instant.
Okay, moving on to the forces of friction. So our ball is soaring through the air, but we all know that flight isn't going to last forever. So what's actually slowing it down? To figure that out, we have to look at the forces that are working against our kick. So it turns out all forces basically fit into two big groups. On one side, you've got contact forces. As the name suggests, they have to physically touch something to work. And then on the other side, you have the really weird ones, non-contact forces. These can work from a distance, almost like magic. The forces that are slowing our soccer ball down, perfect examples of contact forces. As that ball is flying, the air itself is pushing back on it. We call that air resistance. And then when it lands and starts rolling on the grass, the ground creates this rubbing force called friction. Both of them are physically touching the ball, and both are working together to slow it right down.
And now let's talk about those invisible non-contact forces. Because, friction and air resistance explain why the ball slows down, but they don't explain that beautiful curve, that arc it makes as it flies through the sky. For that, we need to look at the forces you literally can't see. And this superstar non-contact force here is, you guessed it, gravity. It's that invisible force that's constantly pulling the soccer ball back down towards the ground. That pull is exactly what gives the ball its arc and makes sure that, what goes up must come down. Another really cool example is magnetism. Think about how magnets can push or pull each other without even touching. So, let's recap. Our ball was pushed by a kick, it was pulled down by gravity, and it was slowed by friction and air resistance. We've officially reached the final moment of its journey, when it comes to a complete and total stop. And here is the last piece of this whole puzzle. The ball stops rolling at the exact moment that all the forces acting on it become balanced. That little bit of forward push that was left is now perfectly canceled out by the push of friction from the grass. All the pushes and pulls are totally equal, which leads to, well, no change at all. And this is really the key takeaway for everything. Balanced forces mean no change in motion. For our soccer ball, that meant staying perfectly still. But, balanced forces also apply to a car that's driving at a perfectly steady speed. The push from the engine is balanced out by the air resistance. The big rule is this: unbalanced forces cause a change, but balanced forces mean things just keep on doing whatever they were already doing. So, as we wrap this up, let's bring it all back to you. What forces do you think are acting on you right now? Well, for one, gravity is constantly pulling you down into your chair. So why aren't you falling through the floor? Because the chair is pushing back up with an equal opposite force.
You, just sitting there, are a perfect example of balanced forces in action. Kind of cool, right? Now, what other invisible pushes and pulls can you spot in the world around you?